Hello everyone. So we are going to start the discussion on the concept of angular acceleration. Basically, angular acceleration is denoted as alpha. Okay, alpha vector because it is a vector quantity. Okay, so we are going to discuss the concept of angular acceleration. See, the rate of change of angular velocity. Basically, alpha is nothing but the rate of change of angular velocity. So, if I write the rate of change of angular velocity, rate of change of angular velocity, alpha. Basically, it is d omega by dt, d omega by dt. This is very well known things which is we study in the mechanics. Okay, so alpha may come. There are two possibilities that alpha may come because of change in magnitude of omega. Yes or no? Because it is also the vector quantity. Omega is also the vector quantity. It may be in clockwise, it may be in anti-clockwise direction. Yes or no? It may be in clockwise, it may be in anti-clockwise. Okay. So alpha may come because of change in magnitude, because of change in magnitude of omega, and the second is change in direction because of change in direction. Yes or no? Change in direction of omega. Okay, so this is a clear concept. Okay, now change in direction of omega is known as precision. Let me tell you, change in direction of omega. I'm here writing in the bracket change in direction. If there is a change in direction of omega, it is known as precision. Sometimes you will see the precision velocity, precision. Okay, it is basically change in direction of omega is known as precision. Let us take a case in which magnitude and the directions of omega both are changing. Okay, so I'm going to consider a case where magnitude as well as the direction of omega is changing. Okay, so now if magnitude and the directions both are changing, so it would be like that. Suppose this is the xy plane, this is xy plane. Here, if the body is here, if a body is here, or you can consider it as a disk or whatever you want to consider. Okay, so assume that it is in rotation in clockwise. It is having rotation clockwise when you see from here. It is having rotation clockwise when you see from here. This is the clockwise rotation. Okay, what is the meaning of precision basically? If you consider this y and this, if you consider this as z, so there will be a plane. There will be a plane which is having a, should be like that. You can see here. This would be the plane of precision. This would be the plane of precision. This is the plane of precision. This is the plane of precision because we are going to rotate this body clockwise directions, and the view is from here to here. We are looking this body from here. This is the direction of view, and this is known as the axis of precision. Axis of precision. Why this is axis of precision? Because the precision is going to be take place about that axis. Okay, so that's why it is axis of precision. Plane of precision, you can see here xz is a plane of precision. Okay, this is a plane of precision, and it would be it is going to be rotated about here like that. It's going to be rotated like that. Okay, so that's why it is a plane of precision, that is denoted as xz, and axis of precision about which it is going to be rotated, that is y. Y is axis of precision. So if I simply draw this, it would be like that, about which the point it is a point O. So why I am going to explain you axis of precision and the plane of precision, because we are going to study the concept of angular acceleration. So here you are able to see that this is the rotation of omega clockwise. This is the rotation. When you looking the body from this direction, there is a rotation of body. Okay. Here also, when the next position of the body is this, here also the rotation of the body will be in clockwise direction. Okay. If this is omega, so there will be a d theta, because the body is going to be rotated through an angle d theta. So here the speed would be omega plus d omega. After dt time, after dt time, the speed becomes omega plus d omega. And you can see here, this is the OX direction, because this is O, this is O, this is OX direction, and this is basically OY direction. Okay. So angular acceleration because of changing magnitude, and angular acceleration because of changing direction of omega, and changing magnitude of omega we will see. So if I'm going to write the angular acceleration because of changing magnitude of omega, angular acceleration because of change in magnitude of omega, change in magnitude of omega. Generally, numerical question is going to be asked in the examinations. Magnitude of omega, so it would be omega plus d omega. We are going to calculate the angular acceleration because of change in magnitude of omega. So omega plus d omega cos of d theta, because you can see in the diagram that when you see, because we are going to consider this direction, so finally it is omega plus d omega is the speed, but we are going to consider, we are having the component along x directions. Okay, along x direction we will consider the component which is the omega plus d omega cos of d theta. Okay, and the initial angular velocity here in the x direction is omega, so it would be minus omega. Okay, and upon dt, because this is a change in magnitude, we are going to consider magnitude of omega which is along the x direction. This is in x direction, or you can say ox direction. Is it clear? This is the angular acceleration just because of change in magnitude of the omega. If you want to calculate angular acceleration because of change in direction of omega, so we will see here angular acceleration because of change in direction, because of change in direction of omega. How can we calculate? We have to consider the vertical component, that is omega plus d omega sine of d theta. Initially there is no vertical component of angular velocity, okay, upon dt, and it would becomes omega plus d omega, and we know that theta is very small, d theta differential angle we are going to consider, so sin d theta would becomes d theta upon dt. Are you getting my point? So when you open the bracket, you will get omega d theta plus d omega d theta, which is also very small. So we can neglect this because both very small differential quantities multiplied together, so it will becomes it can be neglected. So basically you will get angular acceleration, angular acceleration just because of change in direction of omega, because of change in direction of omega, that comes out omega d theta by dt. Yes or no? D theta by dt, and the direction is oy. Oy direction is there. Okay. So what is d theta by dt? We have seen previously that d theta by dt, where it is d theta by dt. D theta by dt, you can see in the diagram. We have rotated this body to an angle d theta. So this is a plane of precision. So when the body is going to be rotated to an angle d theta, so it would becomes angular velocity of precision. Okay. So that's why I can write here d theta by dt is angular velocity of precision, d theta by dt. This is the angular velocity of precision. Okay, so I can write it as omega p. Okay, so this is in y direction, and omega p is, this is very important, angular velocity of precision. Omega p is d theta by dt, change in the angular displacement with time. So what is the total angular acceleration? So now come to the point. So the total angular acceleration becomes alpha is equal to d omega by dt in x direction. So I can represent I cap. So, and the second is just because of change in directions, omega p will be there in y directions. So basically it is the total angular acceleration. This is not acceleration, this is angular acceleration. Okay, just because of magnitude and just because of change in direction of omega. Okay, so there will be d omega by dt in x directions, omega p in y directions. So that's why this term you can see here, I came to know the point, that is it is just known as gyroscopic acceleration. Gyroscopic acceleration is induced just because of change in direction of omega.